So today I'm going to walk you through setting up Klipper firmware on your 3D printer. What Klipper is a pretty cool firmware that divides the workload up between a Raspberry Pi and the microcontroller on your printer and allows you to achieve some pretty amazing results. With Klipper set up on your 3D printer, your print speeds are no longer limited by your processing power, but by the mechanics of the printer itself. So I'm going to be installing this on an MKS Gen 1.4 board. However, Klipper is compatible across many types of boards. However, the instructions may vary a little bit for your particular board. You may already have a Raspberry Pi set up running Octoprint. If not, you're going to want to stop this video and get that set up first. There are plenty of good guides out there on YouTube, so I'm not going to show you how to do that in this video. To start off, boot up your Raspberry Pi and make sure Octoprint is loaded. You also want to have the installation file open and handy, and then we're going to open up a PuTTY terminal. Login is Pi. By default, the password is Raspberry. And from this point, I like to do a double window and start sending over the commands. So I just copy and right-click over to paste. Mine already exists because I have already set this one up. And then we'll send this command. This one takes the longest, so be patient. This is basically going to install everything onto the Raspberry Pi, and then we'll come back and set up the controller on the printer itself. Now, I'm not going to go through the installation process again, so we will continue to flash the microcontroller. What this is going to do is open up a menu configuration so we can select the proper settings for our microcontroller. Here, the architecture is ATmega AVR, ATmega 2560, 16 megahertz, and our baud rate. Sometimes your baud rate, most common baud rate is 115200, but I'm going to be using this one. And we can go ahead and exit. If you made any changes, save first, and OK to save it, and then exit. Then, once you have all your settings, send the make command, and this will basically compile the firmware that it's going to be sending over. Okay. And then at this point, we have Klipper installed on the Octopi, and it's running. We also have our firmware ready to be flashed to our microcontroller. So we're going to stop the service, the Klipper service on the Pi. And then we're going to tell it to flash over. Now, here it says ACM0, but that didn't work for me. I had to use what was already showing in Octoprint, which was TTY USB 0. So I copy this over, USB 0, and hit enter to flash. Now I'm not going to reflash it because I already have it set up on my board, but we'll come back to finish the configuration. And if you run into any errors when flashing, one thing to check is that you are not connected through Octoprint. If it is connected, it'll be using up the serial port that we need to flash over. So make sure that is disconnected. Once the firmware is successfully flashed, restart the Klipper service. And now we have to test if Klipper was successfully installed. To do this, we're going to go over to Octoprint and first add our new printer. And we're going to go here to Serial Connection, scroll all the way down, and I added this here, tmp/printer, and then you hit Save. Then go ahead, reopen the settings, and type here but choose now. You'll have the TMP printer in your drop-down box, and you'll select it, as well as making sure that this box is unchecked here. And hit Save. Then we're going to go ahead and try to connect. And we'll go to the terminal. Now, send the status command, and it says unable to open config file. This means we have successfully flashed our microcontroller, and we can go ahead and set up the configuration file. There are two ways to set up the configuration file. The first way is using just the terminal alone, and the second way would be using a file transfer protocol like FileZilla and a Notepad editor such as Notepad++. The first method is using the terminal. To do this, we have to go to the directory of configuration files. These are already saved on your Raspberry Pi in a folder, and we need to move one of these files to the main folder, the root folder of your Pi, and rename it. So for me, it was generic ramps.config. We use this command here to take the config file from its current folder and copy it into the root folder and rename it printer.config. Now when you're doing this, here it says example, but instead of example, you're going to use the name of your board, in our case, generics-ramps. Now the file is in the correct folder, and we can edit it. But first, I believe we have to go to the root folder using cd. And now we can use Nano, which is a text editor, and here is our configuration file. So if you go back to the GitHub page here, you can see an example configuration file, and this will go through what each of the parameters mean. So I'll go through some of them with you. Over here in the terminal, pretty self-explanatory. Position max, this is going to be your X position, how far your motor can move. The end stop pins here are already set depending on your board type. What you may need to change is the end stop pin logic. So for me, when I first set this up, it was showing my end stops as triggered even though they were open. And the way we fix this is by putting an exclamation mark in front. That just means opposite of whatever the logic is. From there, the rest of the settings you can go through as well. Let's see here. Your nozzle diameter, step distance. Now your step distances may need to be changed. I know in Marlin, step distances are steps per millimeter. This is the inverse of that, so you would take your value from Marlin and take 1 divided by that value to get these values here. Also, you can use your PID settings from Marlin. Put those in right here. And the last thing that we need to change before we can start testing would also be this serial value. For me, it didn't work using ACM0. I had to use USB0. Those are all the things for now that we need to change, and we can change more later. It doesn't require reflashing the firmware like Marlin does, so that is very nice. You can just reopen this in the terminal. Now we'll go out, Control X to exit, save, we'll click Y to save, and we'll hit enter to save it as the same name. Now we have our configuration file set up and we can start testing. Now anytime you make a change to that configuration file, you will have to reboot Klipper on the microcontroller. Now, since we haven't yet established communication between Octoprint and the microcontroller, we're going to use the terminal and use the following command: sudo service Klipper stop, followed by sudo service Klipper start. Now the microcontroller has restarted the Klipper service with the new configuration file, and we can go over to Octoprint and test our connection. So again, TMP printer, the baud rate that we used in the compiler, and we'll hit connect. Now it says connected. That doesn't necessarily mean that we got a good connection. We have to test still. So we'll type a status, and as we hope for, it says printer is ready. You may run into some errors. This could be one of a few things. Possibly you didn't use the correct serial port name in the configuration file. It may also mean your settings over here are not correct. And you can also try restarting or rebooting your system to see if that helps. It can be a little tricky. You may have to do some troubleshooting, but you'll know it's working when it says printer is ready. Okay, now we have everything set up and we are going to do our first tests. The first thing to test, like I mentioned before, would be the end stops. So to do this, we're going to go query underscore end stops. And here it'll show you triggered open open. Looking at my printer right now, I can see that the X carriage is touching, so this should be as expected. If they're inverted, that's when you would go back to your configuration file and change those. So as a reminder, we will go nano printer.cfg, and back here, enable pin is where we would, end stop pin is where we would put the exclamation mark to invert that logic. Once you've made those changes in the configuration file, since you're still connected here in Octoprint, you can now issue a restart command. This is in lieu of doing the sudo Klipper stop and start commands. Now you can check the motion of your motors. First thing would be the X and Y homing. Now before you click on this, you want to be by your printer with your hand on the power button or some sort of reset button, just in case it's going in the wrong direction and you don't have time to issue an M112 command to do that. So I'm going to go ahead and home, and I'm watching my printer home all the X and Y axis successfully. Now, with my X and Y axes at the end stops, my inductive probe is not over the build plate. So make sure that yours is, or make sure you have a end stop switch that will be activated when you hit the X homing button. Otherwise it will come crashing down. If during the homing any of your axes were moving in the incorrect direction, you can change that by adding an exclamation mark right here in front of the pin in the configuration file where it says dir_pin. You just put an exclamation mark right there, save and restart using the terminal.